All right. So the materials that we need for class, you guys went ahead and got that ready for us. Well done. So lesson 8 is titled, How Likely Is It? And that's actually the title of section 2 itself. So we're going to be talking about likelihood. We're going to be talking about chance and probability. So let's take a look at our objective for today, ladies and gents. Okay. So our objective is that you will understand the basic rules of probability. You will learn that previous outcomes do not give information about future outcomes if the events are independent of each other. And we'll talk about what it means for events to be independent of each other, okay? So these are events where, you know, if, for example, if I were to flip a coin, right? If I were to flip a coin and I get a result, like I get heads, and then I flip the coin again, the fact that I get heads the first time is not going to affect whether or not I get heads the second time, right? So those two events are independent of each other, okay? All right, now looking at the essential concept, the why of what we're learning today? Humans do not have a great sense of the concept of probability. Probability measures a long run proportion. Okay, so when we say long run, what we mean is, suppose you have 50% chance, right? 50% chance means that an event happens 50% of the time. So like flipping a coin, it's a 50-50 chance of getting heads or tails. So you have a 50% chance of getting heads or tails in the long run if you repeated it forever. So if I flipped a coin forever, eventually, as I flip that coin forever, that probability, right, that long run probability will mean that 50% of the time I get heads and 50% of the time I get tails. When we don't repeat it forever, we see variability. So if I were to only flip a coin 50 times, I might not get 25 heads and 25 tails. I could get something very different. Maybe in those 50 times, I only get 10 heads and the rest are all tails. So you get more variability, okay? So let's start our lesson with a quick discussion, and we can keep this a chat discussion for now. So I would like you guys to contribute in the chat. So consider possible synonyms for the word chance. If someone says that just happened by chance, what does that mean? Okay, in the chat, I want you to write down what that happened by chance means to you.
Could it be like coincidence?
Sure, absolutely. Was that Dallas?
Yeah.
Just marking it. Luck, yeah, luck. That's one way of looking at it. Possible. Okay. Jay, we're just lucky. Absolutely. Yeah, for sure. Right. What does by chance mean to you? I'm seeing lucky a lot. Randomly. Okay, it happened randomly. Another good word. 50-50. Okay. Anyone else? What does it mean that happened by chance? Okay, so I saw luck a lot, or lucky. I saw a possibility. Okay, I saw random. Okay, so good synonyms, right? So I want you guys to now look at an example here. We have we all played Monopoly or like Candyland, right? Think about the game of Monopoly and Candyland, right? How do you play Monopoly or Candyland? Anyone want to unmute and explain?
You all get a character and you take turns rolling dice, and depending on the number that appears on the dice. That's how many places you move.
So both games require a roll of dice and then movement, right? And your movement is based on what you get for the roll of dice. Okay. What about dominoes?
Dominoes, you're basically matching numbers at the ends, pretty much. So if it's a double five, you're putting whatever domino you have with a five or whatever.
Okay, so you're matching numbers, right?
Mm-hmm.
And how do you pick up your dominoes at the beginning?
Oh, they're all shuffled, or just, yeah, they're all shuffled, and then you just pick randomly face down, so you don't know which ones you get.
Okay, good. So you don't know which ones you're getting, and you get an initial amount, right? Kind of like Uno. And then you kind of have to match the numbers at the ends. Good. Okay. So now that we all have a somewhat of an understanding of how to play Monopoly / Candyland or dominoes, I want you guys to think about which game, dominoes or the board game of Monopoly or Candyland, if you're not as familiar with Monopoly, right? So dominoes or Monopoly / Candyland, which game is more based on chance? And why? Explain why. Okay, I want you guys to write this to me privately. So give me your opinion privately and explain why you think that way. You don't get participation points on this one unless you give me the why. Ooh, Janelle coming through with that good one. Good reasoning, good reasoning. Okay, Dario, I like it. Okay, David, good job. Oh, wrong mouse. Huh, good. Val, thank you. Okay. Okay. Interesting, interesting. Natalie, on the question is the one that's on the screen. Which game, dominoes or board game Monopoly or Candyland, is more based on chance? Which one do you think is more based on chance? Explain why. Interesting. Oh, you guys are coming through with these good reasons. Look at that. Nice. Yes, yes, yes. Oh, these just keep coming through. All good reasonings. Nice. Okay. So it looks like we came to an end with our people that were sharing, and I would have to say, like, it's like almost like an almost even split. Some of you guys are saying dominoes, some of you guys are saying Monopoly. It's pretty interesting. The main reasoning that I'm reading from Monopoly is the fact that a lot of you guys are saying about for the dice. right? The dice you're saying creates more of chance, because you guys are saying that when you roll the dice, you don't really know what you're gonna get, and it's unlikely that, you know, you may want a certain number, but it's very unlikely that you might get that certain number the way that you want it. So you know, you guys are basing the Monopoly chance on the idea that the roll of the die is, you're essentially leaving your fate to chance every time you roll the die, right? And then a lot of you guys for dominoes are saying, well, when you choose your dominoes, you don't know what you're getting, number one, and it's, you kind of leave it to chance when you don't know what your opponent is going to play. So based on the fact that you're picking up your domino pieces randomly, and that your opponent is going to be playing other numbers that you don't know if you're going to have, you're saying that's going to require a little bit more chance. Both of them are really good reasonings, and both of them have merit. So, you know, I would say that though, however, rolling the dice is a little bit more on chance than the dominoes. The dominoes is more of like a, you can kind of like eliminate the possibilities of what your opponent might play the more into the game you get, because you see what's on the table. As opposed to with Monopoly, every time you roll the die, you're kind of giving your success to chance. So every time that you roll that die, it's like a new opportunity for getting the number you want, or not getting it, or ending up in jail or something like that. But both games are definitely chance driven for sure. Good discussion, y'all. Very good discussion. Yes,
Could Yahtzee be a part of like chance?
absolutely. Absolutely. Most games that involve dice or like the roll of die are definitely chance driven. Absolutely. I think Yahtzee rolls die too, right? If I'm remembering correctly. So yeah, for sure. And even Jenga, absolutely. Most games. So then I want you guys, we're gonna do our first IDS journal entry. So you should have your journals open, right? You should have your journals open. And we're gonna do our first IDS journal entry. And that's going to be, I want you to think of situations where chance is the only force at play. Only force, okay? So a game like dominoes, chance is not the only force at play, because you can have strategy in dominoes where you can see which pieces are on the floor and know that, okay, my opponent doesn't have that domino, right? Because it's on the floor. It's like a process of elimination. So that's not only chance driven, right? So think of situations where chance is the only force at play. For example, drawing names out of a hat, right? That's chance, because you have names in a hat and you pull it out, and that's completely by chance. So I want you to write down a few situations where you think this is the case. Okay, I'm going to give you guys a minute, because this is more like a quick think kind of thing, right? Just a minute. Think of some situations that where chance is the only thing at play, and I'm going to choose a few of you guys to share. 1 minute. All right. Nice, Tyrese. That's a perfect one. Okay, so Jade, would you mind sharing what you came up with? You can unmute or write it in the chat. Yes, Janelle, that's a good one too. Jade, are you there, hon? Okay, the other person I want to hear from, Maya. Oh, well, Jade, we talked about that one though. Any other ones that you can think of? Yes, Maya, good. Okay. What about Gabby? Yeah, Nat, that one works too. Ooh, good one, Trinity. Yes, Maya, that one's a good one. So you guys I'm gonna read some of these because you're writing to me privately for most of you guys. So Dungeons and Dragons. Okay, roll the dice, right? Tyrese said that one. Janelle, the game of life. I don't know if you mean the actual board game or actual game of life, because both apply here. Powerball drawings for sure, Trinity. Well done. Flipping a coin. Lottery tickets. Yes, Chris, absolutely. Rock, paper, scissors. Absolutely, yes. Playing cards. Roulette. Good, good, good. Winning the lotto once again. Playing cards. Thank you, Gabby. I'm gonna mark that before I forget that you participated. Calling the radio for sure, Maddie. Jax, yep. Magic, David. No, magic is not by chance. They know exactly what they're doing for magic. Sorry, the board game, absolutely. Roll of dice, casino games, absolutely. Gambling, yep. Yahtzee, Uno, yeah. Bingo. And spin the wheel. Yes, yes, yes. All of these, guys. All of these. Well done. Good plethora of examples there. Let me mark that too before I forget. All right. Good job. Okay, so now we're going to go and we're going to watch a video. It's about a 5-minute video, but it's interesting. It's from a movie called Rosencrantz and Guildenstern Are Dead. Okay, I think it's like kind of like a history period comedy, I think, a little bit.
From Hamlet?
Yeah, a little bit. Shakespeare, for sure. Wow, you knew more than I did. Well done, Dallas.
It's because we're reading it in English.
The Rosencrantz and Guildenstern?
Well, Hamlet, the
You're reading
whole little thing.
This
but
is
they're
meant
in there.
Okay, cool. So someone made actual like movie from it. So we're just gonna watch a bit of it, right? It's only about 5 minutes. So let me hold on, let me pause that. I need to reshare my screen, share sound, optimize for video clip, do that. And then we're gonna open that up nice and large for us. Okay. All right, guys. So let's go for it.
Heads. 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 Bet. Heads I win. Again. Heads. 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 Oops. It must be indicative of something besides the redistribution of wealth. Heads. A weaker man might be moved to re-examine his faith. If in nothing else, at least in the law of probability. Heads. Consider. 1. Probability is a factor which operates within natural forces. 2. Probability is not operating as a factor. 3. We are now held within sub, or supernatural forces. Discuss. What? Look at it this way. If six monkeys, the law of averages, if I've got this right, means that if 6 monkeys were thrown up in the air long enough, they would land on their tails about as often as they would land on their heads. Getting a bit of a bore, isn't it? A bore? Well, what about the suspense? What suspense? It must be the law of diminishing returns. I feel the spell about to be broken. Well, it was an even chance. 78 in a row. A new record, I imagine. Is that what you imagine? A new record? Well, no questions, not a flicker of doubt. I could be wrong. No fear? Fear? Fear. 79.
All right. So with that clip, right? 78 times he flipped the coin and he got 78 heads in a row. So I want you guys to go ahead and we're going to answer the following questions in our IDS journal. Is it possible to get 78 heads in a row when tossing a coin? Yes or no? Explain. Do you think it is likely to get 78 heads in a row? Yes or no? Explain. And if you were to flip a coin one time, what are the chances of getting a heads? What percent of the time would that be? And lastly, since the characters in the clip flipped the coin 78 times, how many times on average should they have gotten a heads? Okay. So I'm going to give you guys 3 minutes to answer these questions, complete sentences in your journal, and then I'm going to call on 4 of you to contribute your answers, okay? So 3 minutes to put these entries into your IDS journal. On the clock, starting now. All right, so that's our 3 minutes. So for our first question, Okay, for our first question, I would like to hear from Evelyn. Evelyn, you can write in the chat or you can unmute. Unmuting would be faster, or you can copy paste. Okay, first question. Evelyn, is it possible to get 78 heads in a row when tossing a coin? Yes or no? Explain. Evelyn, are you there? Got it. Just copy and paste what you wrote from your journal. Okay. So while Evelyn is typing her answer to the first one, for our second question, I'm going to go ahead and let the person know. For the second question, I want Jeremiah to answer the second question, please. Do you think it's likely to get 78 heads in a row? Yes or no? Oh, Jeremiah has left the building. Okay, so then second question then, I'm gonna bring that over to Stephanie. Stephanie for the second question. Okay, Evelyn, she said yes, because there are only two options of what you can get. So yeah, it is possible, right? For the possibility. Stephanie, do you think it's likely? Do you think it's likely to get 78 heads in a row? Well, just think about if you, Steph, if you flip a coin 78 times, right? You flipped a coin 78 times and you got every single time you got heads. Do you think that's likely to happen? Why or why not? Do you think it's likely to flip a coin 78 times and every single time get heads? Okay, why? Why not? Why is it not likely? Okay. Natalie Munoz, Natalie Hun, for question 3, if you were to flip a coin one time, what are the chances of getting a heads? What percent of time would that be? Natalie Hun, are you there? Okay. All right. So Matthew said that the percentage chance would be 50%. Yes, Matthew? Okay. So 50% of the time you should get heads, right? Good. Okay. Tyrese, what can you tell me about the last question? Since the characters in the clip flipped the coin 78 times, how many times on average should they have gotten a heads? if the percentage, right, or if the chances of getting a heads or tails is 50-50, right, or half, how many of their 78 tosses on average should have been heads? Yes, Vicky, good. Yes, Tyrese. Since a coin is 50-50 chance, it should have been on average 39. So at least half, right? Or not at least, half of the flips on average should have been heads. So 39 of them, 39 out of the 78. Good. Okay, good job. So the idea is that, is getting 78 heads possible, like in a row possible? Yes. Is it likely? Probably not. That's like really, really, really difficult to do. And or even get. It's very unlikely to get 78 heads in a row, right? So it's not likely at all, because there's a 50-50 chance, right? Every time you flip a coin, there's a 50% chance of you getting heads and a 50% chance of you getting tails, which means that at like 39 out of the 78 times on average should have been heads, and the other 39 should have been tails. Okay. All right. Very nice. So let's go into some notes. So we want to make sure we get a little bit of probability notes here. Okay, so let's talk about getting to know probability. Understanding the idea of chance helps us get a sense of the concept of probability. So chance is simply the possibility that something will happen. So chance is simply the possibility that something will happen. And probability is a measurement for how often something happens in the long run. So remember, when we said long run, we're talking about forever, right? If you were to repeat that same scenario forever, probability is the measurement of how often something is going to happen in that long run. Okay, so the measurement of probability is expressed as a proportion or percent. So remember, a proportion is a ratio or a fraction. Okay, so 1/2, right? Or 50% or 0.5. Okay, so the measurement of probability is expressed as a proportion or a percent or decimal. So fraction, decimal, or percent. Now, you may already have ideas about how to calculate probabilities based on prior classes or knowledge, but in IDS, we're going to be taking a different approach, and we're going to be using something called simulations. Okay, we're going to be using something called simulations. Now, anyone need more time on this screen? Raise your hand if you need more time on this screen. Okay, I'll give you guys another minute on this screen. All right. If you need more time, remember that you have access to this PowerPoint on your Unit 2, Section 2 slide, or page, I'm sorry. So you can always click the link and open up this PowerPoint and go to this page. So now let's talk about this idea of simulations, right? So let's what is a simulation? Since you don't want to actually flip a coin 78 times, like the actors did in the video, we have our studio that can simulate that for you. So it can simulate 78 coin flips for you. A simulation is a way of creating random events that are close to real life situations without actually doing them. So we can ask our studio to flip a coin for us. And by flip a coin, I'm talking, it's a program. So it'll like flip that 50-50 coin and it'll give us the result. It's kind of like a model, which is a way of representing a real world situation so that predictions can be made. Okay, so a simulation is essentially something that a computer does for us that's very similar to a real life situation. Okay. Do we need a minute for this one as well? Raise your hand if you need more time for this screen. Okay, I'll give you guys another minute. No? I thought I saw someone raise their hand. I guess not. Okay. So let's talk about how we do that in our studio. How would I create the simulation of a coin toss in our studio? So R has a function that does coin flipping for us. This function assumes an equal probability of heads and tails. So it assumes that you have an equal chance of getting heads as you do tails, AKA a 50-50 chance, okay? So this code is R flip 1, okay? R flip parentheses 1. So what we're gonna do is we're gonna log into our studio and we're gonna simulate a coin flip by running the following function of R flip 1. Now you can log into our studio yourself if you want to, okay? If you don't, you can just watch my screen as I do it, okay? So I'm gonna share my screen here. Google. Okay, and we're gonna go to there. We're gonna go to our studio. We're going to log in. Okay, and I'm gonna clear my console here so that we are working from scratch here. All right, so R flip parentheses 1. So it hit enter, there you go. It says flipping one coin, the probability of heads is equal to 0.5. And our result was a T, okay? T stands for tails. That means that the number of heads that we got in this one coin flip was 0 because we got 1 tails, no heads, right? Okay, there you go. That's your R flip function. And we told it to flip it once, okay? So we want to understand our code. So the value of 1 in the argument part in the parentheses of our code, okay, the value of 1 in that argument part in the R flip function tells R to flip the coin only 1 time, okay? So if we wanted to flip more than once, if we wanted to flip 10 times, then we can just simply change the function to R flip 10. And so we would say, okay, now flip the coin 10 times, okay? So we're going to go ahead and we're gonna flip the coin 10 times. And what we're gonna do is we're gonna then answer this question in our IDS journal, the following questions. So we're gonna run the R flip function again using 10 as the number of times to flip the coin. Then we're going to record the responses to the following in our IDS journal. So once we flip the coin 10 times, you're gonna record the number of heads that you got. record the number of tails, T's that you got, okay? In the output, explain what does flipping 10 coins, probability of heads equals 0.5 mean? And I kind of already explained it when I talked about the R flip 1. And then it gives you a scenario. When we ran our R flip 10 function, we got the following output. Number of heads, 3. Proportion of heads, 0.3. What does that mean? Okay. Oops, sorry. And then lastly, what does the output of your R flip 10 function? What was the output of your R flip 10 function? What was the proportion of heads in your output? Okay. So let's go ahead back to RStudio and we're going to run R flip 10 now. And you guys are going to go ahead and you're going to answer those questions in your IDS journal. Okay.
Does
So-
everybody like when you input the code, does everybody's come out different?
Yes. So good
Okay.
question, Alice. Perfect. So I wanted to actually show you. Notice this time I did R flip 10, right? And I got this result and it says number of heads is 5. That means 5 out of these 10 flips were heads, right? So the proportion of heads was 0.5. 5 out of 10 is 0.5 or 50%. But what if I did it again? Same thing, right? R flip 10 in the same exact RStudio, right? I did it again. Look what happened now. Now, flipping 10 coins, it was same probability, right? 50-50 chance. This time, I only got 3 heads. I had heads, tails, tails, heads, tails, 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 heads, tails. So I got 3 heads here, and so my proportion of heads was 0.3, 3 out of 10. Does that make sense? If I did it again, I'll probably get something different. Okay, if I do it again, let me pop this up. Oh, I got 5 heads again, but notice the order in how I got 5 heads is very different than when the first time I did it, right? So you will get something different each time. So I'm going to give you guys 3 minutes to run this code and answer those questions because most of those questions are just quick answers. Okay, 3 minutes for the code starting now. And if you're not running your own RStudio, you can, I'm going to leave this screen up and you can use one of the ones that I just ran for the R flip 10. So going back to our PowerPoint, okay, where were we? We were right here, okay? So you guys each had your own number of heads and your own number of tails, right? Where it says explain what does flipping 10 coins probability of heads equals 0.5 mean? It's essentially just telling you how many times it's flipping the coin, right? And what the probability of each coin flip is. So probability of heads means that for each coin flip, there is a 0.5 or 50% chance of getting heads, right? And then of course, when we have proportion of heads is 0.3, when we got a number of heads, what does that mean? Well, the proportion is essentially just the decimal of if you just put the number of heads you got out of the number of times you flipped your coin. So in this case, it got 3 heads out of the 10 flips. So that's a 3 out of 10, which is a 0.3, right? So the proportion is just the proportion of heads you got compared to the number of flips that you actually did. So now we're going to actually connect it to the video. So relating it back to the video at the beginning, we're going to repeat our simulation, but this time we're going to use 78 coin flips, just like they did in the video. So we're going to do R flip 78, and we want to see what we get. So I'm going to do, you can do R flip 78, I'm going to do R flip 78, and you're going to answer the following 3 questions. How many heads were there? Okay, since we know to expect 39 heads, because that's half of 78, does that value of heads seem reasonable? How many tails were there? And what's the proportion? So you're really just pulling information from the flip, right? From the simulation. So I'm going to give you guys a minute. Once I run the code, I'm going to give you guys a minute to answer this question because it's very quick. It's just putting down information. Let me go back to our studio here. Okay, and I'm going to do R flip now. 78. Okay, so there you go. Flipping 78 coins. Okay, there's the result. Number of heads 41, proportion is 0.5256. So does 41 seem reasonable to you guys? 1 minute starting now. I don't know if you've realized at this point, but your journals this time around are a bit more than just like reflection questions. They're pretty much like your notes as well. So a lot of the examples that we're doing, you're responding in your journal. So it's an additional place for you to take notes with the questions already embedded in there. So the more you engage with your journal, the better it is for you in the long run. Okay, 20 more seconds. Okay. So now that we've ran the R flip of one time, we're going to go ahead and we're going to use that R flip 78 command, and we're going to run the simulation a few more times. So 3 to 5 more times. And then we're going to write down the values for both the number of heads and the proportion of heads. So for example, if we ran the function 3 times and wrote down the following values for the first coin flip. So first coin flip, amount of heads was 45. The proportion of heads was 0.577. That's an example, right? So I'm going to go ahead, and if you're not doing it on your RStudio, I'm just going to run the R flip 78 just a few more times here. Okay, it's thinking, it's thinking. There we go. There's one more time. Okay, R flip 78. There's another time. R flip 78. There's another time. Okay, so those are the 3 new times that I just ran it. If I do any more, it's gonna like not show on the screen. So I'm just gonna keep it at that 3. I'll give you guys a minute to write down the number of heads and the proportion for these 3 or whichever 3 that you ran in your RStudio. Minute for that. All right. So I hope you guys got those down. So as you saw here, we had a few different ones, right? Number of heads was 35, which was 0.448. Number of heads was 33, which was 0.423. Number of heads was 37, which was 0.474, right? So we had differences every time we ran that code. So what we want to take a look at is that the idea of the long run. Okay, so the important thing to note is that the values can and will almost always change each time that you run the simulation to create a new sample. So it's even with you, if you took a coin and you flipped it 78 times and recorded it, and then you did the 78 time flip again and again, every time you're going to get a different outcome of the number of heads and the number of tails. So think about what would happen to the proportion of heads and tails if you were to increase the numbers of times flipped by the coin. So instead of 78, let's say you did R flip 100 or R flip 1000 or R flip 1,000,000, or R flip a billion? What do you think is going to happen to your proportion in the long run? Okay. So I want you guys to think about that and answer the following questions. You're going to go back to the 3 samples of the R flip 78 and you're going to answer these questions. How do the proportions of heads in the samples compare to each other? How do the proportions of heads compare to the true probability of heads, which is 1/2 or 50%? Why is there 50% chance of getting heads during each coin flip? Okay, so I'm going to give you guys 3 minutes. We don't have too much time, but 3 minutes to answer these questions. And then we're going to come back and we'll finish up our lesson. I will share my R flip data one more time with you guys. You're just going to do this very small homework assignment and you're done for the day. Okay. So if you do need this screen, however, I can keep this up just a bit longer. However, if you are done with our notes and you are good to go, you are dismissed. Tomorrow you have a substitute. So please use the sub link on the home page. Okay, your home page will be different. So please use the sub link that's going to be on the sub homepage, okay, to access class and access the substitute Zoom. Okay. Other than that, guys, have a wonderful, wonderful day. No, I do not have a free day tomorrow. I'm still working, and I'll see you guys next week. Bye.
Okay.
Bye. Bye, Trin. Bye, Katie.
Miss K, I have a question real quick.
Yes.
For the for our homework for the 2.8, what is probability? You said that we don't have to post it online, but you want us to put it in our, I'm sorry, put it in the, gosh, I can't even talk.
So the assignment itself is like a discussion.
Okay.
So you're just going to write the tweet as a discussion post.
Okay.
So when you click on the assignment, it'll give you a place to write, and that's where you're going to write it.
Okay, and it's in Canvas?
Yes.
Bye, Miss K.
All right.
Yes, it's in Canvas.
Thank you, Miss K.
See, I actually participated today.
You did. Very good. Keep it up.
And I got used to our studio after all that legwork I had to do.
Good. That's the whole
and by
point.
the way, when I turned it in, was it supposed to say save?
I have no idea. I mean, when you submit it, it should say submitted.
No, it just says save.
Well, there's a button that says submit, so you have to click submit.
No, it just says.
You want to share your screen real quick?
It just says save. It didn't give me a submit option. Yeah.
Okay, make it quick.
Oh, share application. Like, for example, it is, oh wait, it is like,
That says missing. That means it never turned in.
I know, but I did the work though. Hold on.
Where is it? You never submitted it.
Wait, not that one, not that one.
All of those say missing, Matthew. You never submitted them. That's not how you submit the assignments. No. And plus, that's late. All these assignments were due by April 11th. These are late. I'm not taking these.
All right.
There were hard deadlines. April 11th was the hard deadline.
What?
I made that clear. First, it was March 31st, and then I gave you guys an entire other week. And I made it very clear, March 11, midnight,
Oh, all right.
okay? So hopefully those assignments, now that you've done them, will help you be more successful in the upcoming assignments. And make sure you turn those in on time.
Mhm.
All right, hon. Have a good one.
Okay.
Bye.
Gonna go skate.